The alert fired at 10:12 a.m. API latency spike. Requests that normally finished in under 100 milliseconds were suddenly taking several seconds. Within minutes, the support channel filled with complaints. Users could log in, but actions inside the dashboard froze. Some requests timed out entirely. Others eventually succeeded after long delays. The error rate was climbing slowly. The service was clearly degrading. So we opened the logs, except there were none. Our platform ran on AWS. Most of the application lived inside a Kubernetes cluster running on EKS. About 130 pods handled API traffic across several services, including authentication, billing, and analytics. Traffic averaged roughly 3,000 requests per second during normal hours. The system architecture followed a fairly typical pattern. An application load balancer routed traffic to Kubernetes services. The services communicated internally through REST APIs. Postgres, hosted on Amazon RDS, handled transactional data. Redis acted as a caching layer for frequently accessed queries. CI pipelines ran through GitHub Actions. Images were pushed to ECR and deployed automatically using Argo CD. Monitoring consisted of Prometheus for infrastructure metrics and Grafana dashboards to visualize service health. For logs, we used a centralized pipeline. Containers wrote logs to stand it out. Fluent bit agents collected those logs and shipped them into an Elasticsearch cluster, where engineers could search them during incidents. Normally, that logging pipeline was the first place we looked during failures, but that morning, the logs were empty. API latency continued climbing. The dashboard showed slow responses from one of the core back-end services, but the service itself was not crashing. CPU usage looked normal. Memory consumption was stable. Pods were running without restarts, yet requests routed to that service were clearly struggling. We attempted to query the logs for that specific service. Nothing appeared. Not errors, not warnings, not even routine startup messages. At first, we suspected the logging pipeline itself had failed. Maybe FluentBit stopped shipping logs. So we checked other services. Their logs appeared normally, only this particular service produced nothing. That was when the investigation became uncomfortable. A service was misbehaving in production, and we had no logs to explain why. The team began debugging through indirect signals. We inspected metrics instead of logs. Request latency graphs showed that the slowdown occurred only for certain API endpoints. Those endpoints performed heavy database queries. That suggested a database performance issue. But when we examined the database dashboards, query times looked perfectly normal. We then inspected network metrics between the service and Redis. Cache hit rates were unchanged. Nothing obvious explained the slowdown. Meanwhile, the product team escalated. Customers were experiencing long delays when loading analytics reports. Some users gave up before pages finished rendering. Support agents were asking for updates every few minutes. Without logs, the investigation moved slowly. Engineers started adding temporary debug endpoints to the service to inspect runtime behavior. That helped reveal something unexpected. The application was retrying certain operations repeatedly. A single request triggered several retries before finally succeeding. Those retries created the latency spike. But why were the retries happening? Normally, the retry logic would log the underlying failure reason, except this service produced no logs. The root cause traced back to a configuration change introduced during the previous deployment. To reduce noise, an engineer had modified the logging configuration. The intention was to disable debug logs, but the configuration accidentally disabled the entire logging output for that service. At the same time, a minor library update introduced stricter timeout behavior. Requests occasionally exceeded the threshold, and the application retried them. But because logging was off, it stayed silent. The immediate fix was restoring logging output. We rolled back the configuration change and redeployed. Within minutes, logs began appearing again. They confirmed the retry behavior and the specific timeout errors. Next, we adjusted the timeout threshold and reduced the retry count. After deploying that fix, the latency graph began dropping. Requests returned to normal response times. Customer reports stopped. Total incident duration lasted around 40 minutes. What actually failed was not the service, but our observability. The absence of logs removed one of the most critical debugging tools. Metrics alone were not enough. Engineering lessons. Logging pipelines should include alerts when services stop producing logs. Configuration changes affecting observability should undergo the same scrutiny as application code. Applications should emit minimal logs, even at the lowest level. Retry logic should expose metrics for counts and failure reasons. Observability systems must combine logs, metrics, and traces. That day reminded us that debugging production systems becomes nearly impossible when the systems themselves stop telling you what they are doing. Always keep the lights on.